4 with Dr. Paul Rose. So Dr. Paul Rose is a senior lecturer in animal behavior at the University of Exeter and the manager of the Animal Welfare and Ethics Committee for the Wildfowl and Wetlands Trust, where he's also research associate and supervise research for their organization Living Collections. He's a member of the UK government's Zoo Expert Committee and sits on various BIASA, EASA, and AZA committees and working groups, and will give us a talk with the following theme: the relevance of a case study to advancing zoo animal housing and husbandry. Thank you.
Very much. Start my timer. Okay, thanks, folks. Thank you for coming along. So, as was said from my introduction, thanks very much. My name's Paul, and going with the theme of this conference about what's in it for me at the zoo, I thought I would talk a little bit about how we can collect evidence using students, researchers that come into our facilities to put together case studies in a way that enables us to get meaningful data points that enable us to then inform practice. So the kind of overall aim of this talk, and I really hope I'm not teaching anyone in the audience to suck eggs because they know this already, is basically how can we generate meaningful and relevant data that allows for evidence to be credible and valid. And that's super important because anything that underpins husbandry and management must be valid for the species that we are keeping. So how can we stitch together case studies that lots of our undergraduate or postgraduate students do in zoos that ultimately lends itself to the development of species-specific management? So if we think about what we mean by evidence, this is not just a one-off collection of information on one population of animals. This evidence needs to be tested and checked and refined and then replicated across institutions and facilities. So we move away from anecdote and interpretation. We look at casual observations and see what we could take from those, and then we develop methods that are the basis for empirical study, which leads to support for things like best practice husbandry guidelines. So we try to remove the opinion and the subjectivity, and we look at what does data tell us on these animals in terms of their responses to the environment that we keep them in. And therefore, as has been beautifully illustrated by many of the talks that we've had already, we need an understanding of species' natural history and behavioural ecology, how they're best fit to their environment, and also a consideration of their evolutionary adaptations as well. And it's something that I've got on my soapbox about before, that we need to make sure that we are not fitting the animal to the husbandry. The husbandry is the best fit for that species. So all of these inputs that we provide can be assessed and evaluated alongside of the outputs that we see: behavior, inferences on welfare, both physical and psychological, reproductive viability and potential, longevity, physical health methods, that kind of thing. So our basis for looking at case studies and putting these together can help fill in the relevance of these inputs to the species that we are keeping. So in terms of what do I mean by case studies and how do we do them in the zoo, I'm sure many of you are familiar with small scale projects that might run over a couple of months, that might generate something useful for one element of animal care, but actually need to be replicated over time to make sure that what we're seeing is a true characteristic of that population's responses. And speaking from a very British perspective, we are governed by policy and by law, and also by accreditation and membership organisations to do research. We have to do science in our zoos. There's no funding for it, there's very little money for it, so we rely on undergraduates, postgraduates, those kind of projects coming forwards. So we have questions that we need to answer, and a case study is a really nice starting point to work out, is this a proof of concept or a method that we can take forward? And therefore, if we know that we have something that seems to work for one population, how do we go about collaborating to move that forwards? So it's an expectation to do science, but we need to make sure that the outputs from that science, when they are applied, are valid and relevant to the animals that we keep. So if we think about this evidence and what can we do to direct our questions and ask questions that are meaningful, Many of you may be familiar with this paper from Vicky Melfi in Zoobology from 2009, where she shows the marked difference between what species are being housed compared to what species are being researched. So you can see down here, we've got large numbers of research projects on very small numbers of great apes. And we've got huge numbers of individuals of birds, for example, penguins and flamingos, with relatively small amounts of research on them. So there's a disparity in what we are researching and therefore what we know about the care needs of those species. This was updated by myself and some colleagues a few years back, where we looked at a similar thing just to see in the 10 years between Vicky Melfi's original paper and 2019 when this paper came out, had anything changed? And we still see the same change in less research for these more understudied taxa, lots of research on mammals, but actually some taxa such as fish and birds are incredibly speciose in zoos, so we have a lot of different species kept, but we don't seem to be seeing increases in the questions asked on them. And that's kind of worrying from a conservation output, particularly with things like the freshwater fish initiative from the IUCN, where freshwater fish species have been labelled as some of the most threatened species on the planet. So do we need a shift in what we are investigating, and can case studies help us with that? So I thought I would give kind of 3 examples of case studies just to show you what I mean. One that's on dart frogs, chuckwallers and corn snakes, one that's on everyone's favourite pink bird, and one that's on some ducks. And they kind of vary in complexity as I go through. This is going to be a rather whistle-stop tour. Oh, yeah. Like, is that good? Yeah. So let me just waggle it around a bit. There we go. So if we think about how we can give enrichment, and which is a buzzword across zoos, how do we make sure that that enrichment is meaningful and relevant? This was a project that was 3 undergraduate dissertations stitched together. We looked at giving a basking stack to chuckwallers, so that means variation in thermal gradient. How did that impact the animal's time activity budget? We looked at arboreal versus terrestrial space for corn snakes, where we often see these animals kept in very flat plastic containers, but actually in the wild, they like to use vertical height. And we looked at clinical versus naturalistic setups for poison dart frogs. And what you can see on all of these graphs that you probably can't read at the back is marked changes in the animals' space use and activity patterns with alterations to the environment that are more naturalistic. There's nothing new there, but what this shows you is one small-scale case study on an understudied species then provides the foundations for larger, wider-scale study. So it's a nice starting point for something that we can move forward from. And there was a really interesting paper that was published a few years back on snake lengths as a welfare metric in terms of how far snakes can stretch out in Bavaria. So people are starting to think about taking these questions forwards. The next example on the flamingos is an example of naturalistic feeding strategies. So what you can see here is a very artificial setting of birds being fed out of a bowl. They get more room and gradually go to a naturalistic state, filter feeding out in their pool. So this increase in naturalism in feeding style by embedding natural history into how food is presented showed that aggression levels drop and foraging rates increase. This has an impact on bird coloration, so the more naturalistic the style of feeding, the more pinker the flamingos can become, and there is less wastage as well, because you are not feeding out pellets that birds are squabbling over, which then other freeloading species in the exhibit might be consuming. The caveat comes with this, depending on whether or not your exhibit is netted, or whether or not it's mixed species, and what type of flamingo that you are keeping. But we have clearly shown that the more artificial the feeding style, the more change in the time activity budget of the bird occurs away from how wild flamingos would feed. And wild flamingos will naturally maintain individual distances between foraging birds to reduce levels of aggression. And if you have a breeding flock, juveniles will actively move away from adults to feed not where the adults are foraging. Thank you. So then we are looking at case studies across a range of institutions. So what we have here is a nice example of a multi-student study that looked at 19 species of ducks across 3 centres. And this compared wild birds from a literature review and direct observation with what the captive birds were doing. And what we showed here in their time budget was there are some similarities, but also marked behavioural differences. So we looked at all of these key predictors that consider season or sex or species ecology, foraging niche in the wild, etc., etc. And we see that there are some things that suggest that enclosures for wildfowl in zoos are deficient from a behavioural perspective. Much more inactivity, less time spent feeding and foraging than we would see in wild birds. So this is kind of my biggest case study of a range of student projects stitched together. Bless you. So to kind of conclude, how do we do this? How do we put these case studies together? Well, we can focus on a directed question. So this is a paper right from the start of my PhD back in 2014, again on flamingo welfare. And this is a very messy slide, but if I just go through it briefly, what you can see right at the top is the overall question, which is how do we infer and evidence positive states in flamingos? These are all of the different aspects of husbandry that we should consider investigating: foot health, plumage colour, social bonds, enclosure usage, etc., etc. And then how do we get the methods to stitch together in a way that's valid and repeatable for others to follow? So you can have a look more about that if you're interested in the paper in the International Zoo Yearbook. We can then show a difference in research output. So if I take you back to that original Vicky Melfi paper from 2009, loads of flamingos in captivity, hardly any research. This was a paper I put together back in 2021, and now we can see we've gone the other way. So are flamingos now the new chimpanzees in zoo research, where everybody studies the chimpanzees, now everybody's studying the flamingos? So maybe I do need to get off my soapbox and find a different species to talk about, because perhaps we have answered some of these questions. So ultimately, my key points to success really when you put a case study together: focus on a particular question, have a clear method that is standardized, and make sure that you do training and inter-observer reliability for when there's multiple people collecting data. Always check any drift from original instructions, particularly if there's an ethogram that might be quite complex, and check whether or not your method in your case study can then be applied to other systems. So we did some work at Slimbridge, one of the centres that I'm based at, that looked at trail cameras to understand nocturnal behaviour in flamingos. And we used that on one species. It worked really well. And we used that on another species. So we took it from a population of greater flamingos and we used it on a population of lesser flamingos. And both of those articles there are open access if you'd like to see how the method's transferred. This is really useful, I think, because we can take these questions and publish them. For example, the IARSA Bear Tag and the Polar Bear EEP have put together a polar bear research prospectus. If you've not looked at it, I think it's brilliant. Questions for the zoo that can inform management in the wild, questions from the wild that can inform management and conservation in the zoo. And perhaps with case studies to move us forwards, we could do this kind of document for a wider range of species. So I hope I've shown you there are some opportunities and challenges to this. We must make sure that case studies are small, they might need replication, they might be very specific to the animals in our care, but they can encourage buy-in to other larger research questions. And so long as we've done training to make sure there's no drift away from methods, to remember that we are doing multiple repeated measures on the same population, we can then get something that is a method that could be used across zoos in a standardized way. And we also seem to have an issue with student enthusiasm for projects as well. I don't know if other people have found this. Projects that you think are useful and relevant don't always seem to appeal to the student body that you would like to collect the data. And I think that's something that we could maybe talk about or discuss in the future. How do you sell these important questions to students to try and get this husbandry evidence in the first place? So in conclusion, we have an initial investigation that we start, and we think about maximizing our potential workforce, i.e. the people that we have around us to collect data. We try to document some positive change Can that lead to further study in a valid and repeatable way? And then we review it. We ask for help and advice from others that know the species or know the system. And we do our best to check the reliability of what we are calling evidence. Because anything that goes back into changing, adapting, or evolving animal care must be relevant, must be trustworthy, and must be valid. So I'm more than happy to chat to people about that at any point. My email address is on the slide. But thank you very much for listening to my whistle-stop tour on how to get a research program started from a small-scale basis. Thank you very much.
Thank you very much. So we have time for one quick question.
Thanks. That was a great talk. I'm just curious, are there efforts to, in addition to kind of sharing and repeating positive findings, are there situations where there's a intervention where there's no change in behavior, and how does that information get shared more broadly so people aren't trying the same thing over and over that maybe isn't working?
Yeah, no, thank you. That's a great question. So for many years, I was the chair of the Biasa Research Committee, and we have a workshop, an annual workshop. And one of the things that we'd always try to do within that conference was to have a discussion on what is evidence to then develop methods. And those methods were then published in a zoo research handbook. And the information that went into that zoo research handbook were things that have worked that you could then try in practice in your own facility. But I think it's a really important point that people don't always want to talk about the things that haven't worked, but we should. And there are now some journals, so Ethology, for example, the journal Ethology has a section on non-significant. So they actively encourage non-significant papers. And I think that would be a really nice way to move forward more broadly across the peer-reviewed academic literature to encourage people to publish things that haven't worked. So as you say, we don't reinvent the wheel. But yes, certainly the meetings and the symposia for some of the zoo organizations do talk about things that have been trialed and haven't worked. So maybe think about another avenue in the future.
Any more questions? Okay, thank you very much. So now we are going for the last talk before lunch with João. João Meireles studied biology at the University of Lisbon and animal behavior and conservation at the University of Utrecht. Currently is doing research on zoo population sustainability at Zurich University, and will give us a talk with the following theme: what zoo data can tell you about your animals and your populations.
Yes, so thank you very much for having me. So what I expect from this presentation is to show you and tell you some stories of some work I have done with data from zoos and how that data can help us to know better about the animals we manage and we take care for. So, and to start to create a different framing between populations and individuals. So a bit as a following up from also from where Paul started. So it's important to make a distinction with what is an anecdote from expertise. And I will tell you a small story. So basically imagine that you have a keeper that has a pair of okapis and takes for them for over 10 years. And he has been very successful in keeping them healthy. He knows very well his animals, their food preferences, their typical behaviors, etc. And the keeper finds out that actually their animals love fruit. It's very easy to train them, to manage them, to make them cooperate. Every time he gives fruit, they engage a lot with the enrichment devices when with the use of fruit. Enrichment devices when with the Sorry? Okay. So over the years, the keeper might build the belief that okapis love fruit. They thrive on fruit, and fruit is part of the normal diet for these species. However, if you start collecting research for from several zoos and several okapi, research has shown that high consumption of fruit is associated with digestive health issues, hoof problems, obesity, and even oral stereotypies. So this keeper cannot claim he's an expert on the species, only on the experience he has with his two okapis. He needs to collect data and expertise from a broader number of animals to be able to say that he's an expert on the species. And the best he can say is that he is an expert on his two animals. But and just to conclude, the right thing to do with okapis is to give them plenty and plenty of browse instead of fruit. But saying this, I don't mean that our zoos are not full of unique individual animals. Quite for the contrary. There are animals that are completely unique with unique characteristics and unique needs. And some of them even become world famous, especially thanks to social media nowadays. And there is no doubt that these individuals require unique care for their welfare. And there is also no doubt that their keepers that are there every day are the most expert people on this world to take care of them. But it's when we collect data from several individuals over time and across multiple institutions that we start producing good volumes of data. And zoos have been doing that through institutional record keeping, recording how much food is offered, how much is consumed, temperatures, pHs, etc. Zoos and breeding programs have a lot of breeding data and genetic data in international and regional stud books. And then we have Species 360 and ZIMS, which is a online database where every institution member inputs data of their animals in there. And it's only through these that we can really have a global scale amount of data to analyze. And it's thanks to this amount of data that which is available tool that we are able to have managed populations that are meaningful for conservation. And after this introduction, so some of the examples of work I have done with data mostly from ZIMS, but not only. So starting with comparison of body mass between zoo animals and wild populations. And so using the pygmy hippo as an example, if you are not familiar with the Thai language, Modang means chubby pig. And well, when comparing photos of wild pygmy hippos, which are not that many because they are hard to study in the wild, with zoo pygmy hippos, well, indeed, zoo pygmy hippos are a bit, well, chubby. And then we compare data. So the wild data is those two thin lines because, again, there is very, very few data for wild specimens. But what we can see is that most captive individuals are well above those wild references, let's say, which suggests we probably are not doing something right with our animals. And here, two other examples from two other species, the common hippo and the black rhinoceros, where, well, the difference between zoo and wild populations is not so drastic. But not everything is that bad. So this is the evolution of the body mass of the pygmy hippo zoo population over time. And what we see is a declining trend, which shows that, well, we are changing something and towards the right direction. And in 2013, there was some research on pygmy hippo diets, and they found out that by changing the composition of the diet, weight loss is achievable, all of this information was integrated in the International Stud for the Species, and perhaps it's the reason why we are seeing these population trends. And nowadays, going around the world, we can see pygmy hippos in zoos that are leaner and more elegant, let's say, than before. And so another research I have done was on historical population trends, mostly focusing on survivorship. So here, this is not my research, but it's a good example. It shows how the survivorship of zoo African elephants has evolved across about the last century. And if you focus only on the colored lines, we see that the zoo elephants that were born more recently have a higher survivorship than older cohorts of elephants. And we believe that this is strongly associated with improvements in elephant husbandry that happened across the last century. And so my goal was to look to this on the same for hippos. And well, this is kind of what hippo husbandry used to be. Some examples not so long ago still, but well, there were lots of improvements. But were these improvements visible on the survivorship of the zoo population? That's the question. So I did the survivorship analysis, and this is the oldest cohort of common hippos in zoos. And then the 60s and 70s, the 80s and 90s, and, well, the most recent cohort. And, well, we don't see any improvements. This is not necessarily negative. What we believe is that hippos are very resistant and sturdy, and perhaps they were always well suited to any condition that we humans choose to give them. And that's the reason why perhaps we don't see a difference in adult survivorship. And here for pygmy hippos, not a lot of change, but, well, most recently, that is statistically significant, and this species has received some research in recent years, and there was the production of a best practices guidelines, and we believe this is the reason why we see these improvements. When looking to juvenile survivorship, for common hippo, we see an improvement. For pygmy hippos, there is also not so much, but also a considerable improvement, especially compared to the oldest cohort. Here, another example of another small thing I did was looking at the manatee EEP. So there is a group of individuals that is related to a male that has autoimmune disease. And this is the juveniles of the population. And we see that the juveniles that are suspected to be related to that individual have a higher mortality than those that aren't. And next is a project that I also did before, and it was related with pair compatibility in breeding programs, especially in the Okapi breeding program. So in a nutshell, breeding, the planning of breeding programs involves, well, someone that does the genetic analysis in the computer, assessment of reproductive health, the transport of the animals, monitoring of hormone cycles to find out when is the right time for things to happen, the actual pairing of the animals. And all of this takes a lot of work and time and logistics and money as well. But sometimes, well, things don't go well. And even more, sometimes things go quite drastically bad. So even if we do all the genetics to pair the right animals, in the end of the day, they might not want to mate with each other, and all of the work that we did before is just wasted because the animals don't cooperate. So, and this happens because most research suggests that, like, we are not offering mate choice in our breeding programs. And mate choice has been associated with higher fecundity, higher offspring survival if the species offers parental care, if both parents offer parental care, and overall offer of options and choice improves animal welfare as well. And why is it difficult to implement in zoos? Well, each zoo has a limited number of animals to choose from. Often the way we house the animals also doesn't promote right pairing and communication between the individuals. There is still a huge lack of understanding of mating systems among the thousands of species we keep in our zoos. And that lack of understanding leads us to do bad decisions in managing them. And then often genetics is taken as a priority, and when letting the animals choose freely, they might not choose the partner that is genetically better for the breeding program. So the balance is to try to find a solution that can accommodate both things. And the example there is from research made with giant pandas, and it shows that at least for 2 of the metrics, they analyzed when the female is mated with her preferred partner, she performs better in reproduction. So, and this, we arrived to the Okapi breeding program, which is coordinated by Zoo Antwerp. And it has been a very successful breeding program. It started in the 80s, and you can even see on the plot the population just is going through the roof, which is positive. However, there has been instances, and you can watch the video. So basically, the male becomes aggressive towards the female and starts attacking the female. And no mating occurs. Here, just more of the video. And I mean, this is dangerous for the animals, of course, because they can hurt each other. This was actually quite problematic male. They tried multiple times with multiple females, and he always, was aggressive towards many females. So my goal was to look at the history of each okapi pair in the program in Europe, and through looking at the stud book for the species, a questionnaire run through all the zoos that hold the species, and even doing some keeper interviews, because while some zoos are very good at record keeping even this type of information, how the animals perform during mating introductions, other zoos don't keep any track of it. So I had to rely on literally interviewing keepers, even retired keepers, to get to know a bit more about the history of each pair. So this is the stud book, the questionnaire I did, asking for if the enclosure allows visual or physical interaction with the animals when they are separated, a rank of how aggressive, how much aggressiveness was observed, if the animals when they were young were introduced to other animals than their mothers only, because often socialization at a young age is associated to better performance at breeding behavior. And yes, a lot of interviews asking, well, what happened with this pair? Do you have any idea if they ever engaged badly with each other or not? And these are the things in the end that I tested: the age difference between the pair, if both male and female at young age were socialized with other individuals of the same species, because often the female is kept in isolation when after parturition, and only when the calf is weaned or transferred to the next zoo, it encounters for the first time a new okapi that it's not its mother. So this was interesting to test as well. And then something that I call estrus or mating husbandry. So basically, I still have 5 minutes here. Okay, so So the species is solitary, and most zoos or some zoos, perhaps I can start showing results, so that helps to explain as well. So in the end, okay, it's not there yet. So about a third of the pairs of the program that I researched have displayed some sort of aggression during breeding introductions. And I did a GLMM test, and oops, sorry. The only variable that was significant was the estrus husbandry, and well, now explaining what is the estrus husbandry. So as you can see as well, about half of the zoos, they only introduce the female or the male to the female when she is on estrus, while other zoos give the animals chance to meet each other regularly, independently of the breeding status of the female. And what we found that is actually the zoo or the pairs that are managed in a way that the animals have regular contact with each other are the ones that display less aggressive behavior. And we think this is because so when the animals have more opportunities to meet each other, they exchange information about each other. The male can regularly assess the reproductive status of the female, etc. And although the species is solitary in the wild, we believe that being solitary is not the same as being asocial. And since the home range of the male covers the home range of several females, he might come across them regularly to inspect them. So, and we try to integrate this in the husbandry for the breeding program. And to finalize, so just some short examples of how I also used some data to integrate into best practices guidelines, because on the side of doing this project with the OCAPI program, I also helped develop the OCAPI best practices guidelines. So, which is a document that compiles and tries to uniformize all the information about the husbandry of the species, nutrition, housing, etc. And so I try to input some data there as well. This is the growth profile for calves in their first 2 years of age. So any keeper that has a calf can compare with this data and see if his calf is developing well. Here an example of change in body mass across pregnancy of 3 females that I also put in the best practice guidelines. And then here, after the pandemic, probably, well, it happened with me, but possibly with many of us, we came up a little bit heavier as well. So after the pandemic, I decided that I had to change some habits, and so I improved my diet and I did some more exercise, and I was tracking my weight daily. And as you can see, in 3 months, 6 kilos of João went away. But then, well, I thought, well, 61 is okay, I'm fine, and I think I can keep doing this lifestyle. And I stopped tracking my body weight, and well, things got not so pretty again. But so what I learned from here is that basically, if you don't track what you are doing, you just eventually get lost. And well, giving you an example from the zoo world. So this is an example in Basel Zoo. They found out that the calves of lesser kudu were often dying from vitamin E deficiency. So they improved the diets to include more supplementation of vitamin E, but over the time they changed the team, the keepers, and the same method was not kept over time, and calves started dying again. Nobody tracked the composition of the diets. Nobody did hematological analysis of the animals, etc. And a couple of years later, they were faced again with the same problem, and they had to re-implement the same solution. So these are the 2 main messages I want you to take home, is that, well, you only know if you are moving towards improvement if you measure it. And collecting data in the zoo is not a waste of time. It's very useful for those that daily take care of the animals. It's useful for research, for conservation, and one day that data that you produce might down the line improve and make your job easier. So thank you very much for your attention. I hope you enjoyed, and any questions, please.
So I know we are closing in on lunch, but we have time for one or two quick questions if someone has it.
I'm not entitled to give dietary or fitness advice.
Okay, then we can go to lunch. Obrigado, João.
Welcome.
So, so
hello, everybody. Welcome back from lunch. We will start now with session 5. Our next speaker is Rosaria Santoro. She's a dedicated biologist with a PhD in conservation biology from Manchester Metropolitan University in the UK. And she has nearly 8 years of research experience in EAZA zoos. She has developed conservation projects that use acoustics and behavioral techniques to improve animal welfare and expand species knowledge. Her presentation today is titled Ethogram of Pygmy Hippopotamus, Understanding Behavioral and Acoustic Communication for Conservation. Okay, so we will go on to the next presentation by Dr. Marianne Freeman. Marianne is the subject lead of the Zoo and Animal Science degrees at the University Centre Sparsholt. Hopefully I said that correctly. Prior to this role, she was Senior Education Officer at the RZSS, where she enjoyed passing on her enthusiasm for the zoo industry to post-16-year-olds. Having a passion for zoo research, since she was research coordinator at Blackpool Zoo more than 20 years ago, and more recently as section editor for the Journal of Zoo and Aquarium Research, she has been keen to help develop the field of zoo research. So please join me in welcoming Dr. Marianne Freeman.
Oh, yeah. Thank you. Can you hear me okay? Great. Okay, thank you very much, Edu, and thank you for inviting me along to this conference. As you've heard, I've been involved in zoo research for quite a long time now, and I've had the opportunity to see zoo research from a variety of stakeholder viewpoints, so from being records and research officer, from conducting research as a student myself, and now from teaching through the zoo-based courses that I lecture with. So it's given me a kind of opportunity to really kind of see some of the potential challenges and hopeful opportunities that we can move forward with zoo research in the future. So sticking with the theme and what's in it for me in this conference, I'm hopefully going to be able to present some opportunities that you could get involved in as well if you want to help overcome some of the challenges. Okay, so it's a really relatively young field, actually. If we look at the field of science as a whole, zoo research has really only been going for the last 40 or so years. Zoo biology was one of the first publications specifically for zoo-based research, and it started up in 1982. As Marcus pointed out yesterday, the wild mammals management book that came out in 1996 had a chapter on zoo research in there. And when we just do a quick kind of search on Web of Science for the term zoo in research and see what comes out, and I've taken out Galaxy Zoo, which is an astronomy citizen science project, but you can see the trend for zoo research increasing over time. Note the kind of increased blip in COVID times where people probably had a whole load of research on their desk that they had time to write up, and then a bit of a dip afterwards when we had a bit of a dearth of being able to collect data. But that's still increasing. And of course, this trend is increasing across any kind of science-based research because there is an increased pressure to publish, as we know, but we're still seeing research on the increase. If we just look at the topics that is studied within collections, the bottom graph was taken from the BIAZA database. of zoo research projects that have been put forward by collections across the UK and Ireland. And over the last 40 years, over 5,000 different studies have been put forward to this database. Half of those are behavioural-based projects, but if you remove the behaviour-based projects, you can see a wide range of different research topics, from husbandry and enclosure design, enrichment. We've got visitor studies now becoming more and more prevalent. Studies into conservation, and a whole range of studies in relation to animal health as well. So we can see that zoo research is also really unique, as well as being very new, really unique in the fact that it covers a wide range of different research topics. And if we actually take and expand this graph even further and look at some of those one-off projects, we've got things like theology, music, engineering. So there's a whole range of different kind of fields that use the zoo for research. And that research can range from social science to biological sciences to clinical experimentation and observational research. But we need to make sure that we maintain the quality in zoo research, and it is often criticised for small sample sizes. And what we need to think about really is what that sample size is. So I think it was Katarina that mentioned pseudo-replication earlier on, and I'm really glad that that came up, because that is something that we need to think about if we're studying a troop of chimpanzees. Their behavior impacts on each other. And so actually, really, you're studying a sample size of 1 if you want to generalize back to the kind of wider global zoo population. So of course, we can generalize back to that individual troop based on the sample sizes of time and observations that we've done, but we just need to think about what our inferences are from our studies. And so the trouble with small sample sizes is that it limits the kind of variation that we're able to see across the populations. It makes it hard to make generalizations back to that wider population, and potentially could violate statistical assumptions, leaving us with like type 1 or type 2 errors within our studies. And a kind of crisis, although I should probably be more optimistic and not use the word crisis if John's in the room still. The replication crisis is something that we see across science in general. And there was a study in Nature that showed that 70% of researchers were unable to replicate a study and find the same outcomes. In fact, half of those couldn't even replicate their own study, which is a little bit worrying. But some of the problems that we see with in terms of being able to replicate and get to the same findings come down to kind of analysis bias. So potentially analyzing a data set and then selectively cherry picking the results to find the results that kind of have the best story to tell and use that in the manuscript. We could have studies that are underpowered because we don't have enough of a sample size to look at that variation to see the effect size that we're maybe looking for to find the result. Those studies might be written up with unclear methods. Or there might be kind of lack of standardization, as Paul mentioned earlier, in terms of making sure there's not drift away from those methods. So we do have these potential challenges, but there are potential solutions within this field as well. And this is something that I've been kind of quite interested in for the last 5 years, working in other areas of animal science. So working with canine science and working in farm animal science. I've been able to see some of the different kind of initiatives that have come up. And some of these initiatives have been based around kind of big team science. And the way that big team science works is that you have multiple researchers in different sites all working together on the same project. And the image there over on the right is from a paper that I published with a group just a few months ago, where we are looking at comparative cognition and setting out some of those challenges and potential opportunities that we have in terms of collecting data from multiple different taxa using the same standardized methodology. So the way that this works is that a team can get together from all areas of the world and plan out particular questions and plan out particular methods to address those questions, and everyone agrees and collaborates to get those methods. And then individual sites can then put forward to collect the data, and that data then comes together in one central location. It's analysed collaboratively and it's written up collaboratively. And then everybody that gets involved has the opportunity to then be on as an author as well. So there's an incentive as well behind that. So there's been a number of these different many projects. This is the Many Minis project, but there's also taxa specific, many dogs, many fishies, many birds, many goats as well. So if you're interested in any of those animals or you'd like to get involved in comparative cognition, come and see me about any of these projects. But then we can take that and we can apply that into kind of a zoo specific setting. And if we look back into 2010 when IAZA produced the research strategy, one of the key things that they were emphasizing was that zoo research isn't just about increasing our knowledge of our visitors or biology, but it's also important that that research is robust and can have a positive effect on the public opinion as well. But multi-site zoo research is one of those ways that we can gather larger data sets. And it's been really nice to hear about some of the different multi-site research projects that have been presented through this conference. But when we think about multi-site research projects, often it's one individual researcher taking their own time to go out to multiple different collections to gather that data. So you're still limited by funds, limited by logistics and time to be able to collect that data. Or it could be multiple sites via surveys, but then you're limited by the kind of rich quality data that you can get back from that. Or there have been the occasional times where it's been multiple sites where one researcher has initiated a project and then got either equipment or a method out to different collections to be able to have them collect the data. When we kind of look at the field of zoo research as a whole and try and see how much of a global impact we've had, taking that zoo search in Web of Science that I did earlier, we can see where zoo research is coming out across the world, and the USA is really kind of leading in terms of more than half of the publications that come out are coming out of the USA. However, it was really encouraging to see that Brazil was kind of the second most common place of producing zoo-based research, but that was still just a tenth of all the research that is coming out. If we put Europe together, the amount of research coming out of Europe as a whole is pretty much equivalent to that of the USA. But it's really important as well to be able to see a global impact of zoo research, to have a global viewpoint of zoo research as well. So by getting networks together from individuals working in zoos right the way across the world, we're able to get a better picture. And we can test particular aspects that might relate to getting evidence back for our management, just as Paul was saying earlier on. There's a conservation evidence publication who have been searching through a whole variety of different publications looking for specific examples of where in ex situ conservation efforts have actually had an impact or perhaps didn't have an impact. And that's a really nice starting point for seeing where we can be more strategic about the types of research that we look at. Equally, we now have regional collection plans and research strategies coming out of those. They are slow to disseminate back to institutions and academic organizations so that we can be more strategic. So one of the things that we have done on the back of these many projects is come up with the Many Zoos initiative. So this is a collaborative initiative that anyone can get involved in. If you're interested, scan the QR code down there. So far we have about 70 researchers involved in the project right the way across the world, so from the US through Europe into Africa and Asia and even Australia, but we're always looking for more people to get involved. And this is going to work in the same way that the other many projects work, in that we can collaboratively come up with particular research questions. We can collaboratively come up with the methods to answer and address those questions, send out calls to individual sites to be able to collect the data, make sure that that data is being collected in a standardized way by testing samples of that data, analyzing the data collectively and writing up. And you can get involved at any point. So you could get involved in the writing or the analysis or just the data collection, whatever works for your particular skill set. And so that's the beauty of this. And it's also an opportunity to network with individuals in zoo research as well. And I think I've just got enough time to talk about another project that we're also involved in, because we know that there are potentially biases in the analysis as well. There have been several studies actually looking at how people analyze the data to see if there's consistency. And one study was called the multi-100 study, where they took 100 behavioral-based research projects and got another 500 different people to analyze the data that was publicly available to see if they would come to the same conclusions. only 34 out of those original 100 papers were able to be reanalyzed to find the same conclusion as that original study. And in fact, only 4% of the reanalysis actually found the same effect size. So we've got variation across the way that data is being analysed. But is this still the case in zoo research, or actually are we more consistent in the way that we analyse zoo data? I'm just going to skip forward those bits. So we have, Paul and I have come up with this many zoo analyst project. Now, actually, before I jump onto this, how many people have published in the room? Okay, for those of you that have published, did you publish your data alongside it, or did you put your data, keep your hands up? Okay, less people sometimes. Anyone put a statement that said data available on request? Anyone requested your data? Okay. Okay, so yeah, we don't seem to actually look into the data. And if we're not publishing the data or presenting the data alongside our results, actually, how do we know that those results were actually analysed appropriately? Some journals have now started asking for the data and asking reviewers to check the data and confirm that the methods were appropriate that way as well. And so that might be a way of ensuring consistency within the field. But this project is not to test your statistical analysis abilities. This project is actually, what we're going to be doing is looking at one sort of standard behavioural data set. And we want as many people that are in zoo research as possible to actually analyse that data set. And we're interested to see the types of variation that we see in analysis. So what different choices do you make if there's missing data? What kind of tests do you choose? What kind of calculations do you pick through? How do you clean up the data? So we want to know, actually, is there a wide variation in the way that zoo research is analysed, or actually is it much more consistent? So there's no right or wrong way to do this. It's still early days. We're still kind of at the planning stages. So if you want to get involved in planning stages, you can get on board with that. If you want to be highlighted as an analyst at a later stage, then let us know as well. But this is just one way to kind of look at the consistency within zoo research and actually see what the effects are of variation of the studies and the implications that that has on management decisions. I'm going to stop there because I think I'm almost out of time. But thank you very much, and happy to take any questions.
Thank you, Marianne, for your presentation. Does anyone have any questions for her? Yeah?
Not running away yet.
Thanks for the great talk. Regarding the Many Zoos project, you mentioned one concept study. Can you tell more about that? Is it about comparative cognition?
Yeah, so actually, we have a study that's been kind of piloted already just to test out the network and see how well the whole process actually works. So it is a sort of social behavioral cognition project that we're looking at just now, but we're still at the moment planning for the next project. So if you've got ideas of particular projects that you think that are really necessary, then that can be an opportunity to get involved and help lead the way for the next one. But yeah, we've just got a small study just to test it out to see how well the whole process works.
Okay, thanks.
Thanks.
Are there any other questions? Okay, well, thank you very much, Marianne. We have a small gift for you as well.
So now we have the next presentation from Freja and Kamille. Freja is a soon-to-be master in biology at the University of Copenhagen, holding a bachelor's degree in biology and animal science. Alongside her studies, she has worked at Frendved, sharing knowledge about the ocean, and at Knuthenborg Safari Park, educating visitors about animals. She currently works as a natural science educator at the Natural History Museum of Denmark, where she also organizes a volunteer group answering public science questions. Kamille is a soon-to-be master in animal science, also at the University of Copenhagen. Raised by two biologists and surrounded by animals, she developed a great interest in animal welfare training and human-animal relations. And both of them are going to give us a talk with the following theme: welfare assessment of zoo house giraffes.
So thank you for the introduction, and thank you for having us here. We're very happy to be here to present our master project. So we are one of the student projects that Paul Rose talked about earlier, and we have been working on welfare assessment of zoo house giraffes, and we have been lucky to work with this great group of supervisors, where Elodie has just given a talk earlier. Okay, first I want to say something about the background of the project. So in general, there's an increasing interest in like animal welfare and focus on animal welfare. This is also, as you know, the case in zoos. And it's also becoming a like requirement for accreditation in different associations, both like globally with the World Association of Zoos and Aquariums, but also with the Danish Association of Zoos and Aquariums. And the Danish Association really wants like species-specific welfare assessments. And as of now, it's not like there's not many comprehensive species-specific welfare protocols for zoo-housed animals. So our project will hopefully be a contribution to the giraffe project, or like to a giraffe welfare assessment. Yeah, so that's our focus. And this is just to show you where we are within like the animal welfare concept, because animal welfare is very broad and there could be like multiple presentations on this. We have used this 5 domains model as a starting point. And this model or framework is very like widely used in the zoo world. It's also recommended by the World Association of Zoos and Aquariums. And this model kind of is like based on the mental state of the animal. So it's like defining welfare as a mental experience, as a subjective experience. And it's a way of like structuring what we can measure, or what we can look at the animals, and how that feed into like welfare and the mental experiences. So the parts that we can actually measure are like nutrition, environment, physical health, and behavior. And from those measurements, we can infer something about the mental state. We can't say something absolute. And our project focuses on the behavioral domain, not because we don't think the others are important, but because we had to like limit ourselves because it's only a master project. So the first thing we did in this project was to identify relevant behavioral indicators to use for giraffes. And we did that by reviewing existing literature, searched in some databases with a lot of search words, as you can see here on the slide. We also used like reference searches, so we looked through all the references on the papers we identified to try and like get everything on giraffes. And while doing this literature review, we kept these aspects of welfare indicators in mind. And these are some of the important aspects if welfare indicators can actually be used to say something about animal welfare. So validity is a very important aspect. So whether the indicator measures what it is supposed to measure in animal welfare, and also reliability or repeatability, as Paul Rose also said earlier, whether an indicator can be like measured or used consistently, both like between observers, but also over time. And a final very important aspect is feasibility. So whether an indicator is practical to use in like the everyday life in a zoo, because often there's not like unlimited resources and time for this. Yeah, so we identified 7 behavioral welfare indicators: social interactions, environmental interaction, feeding, rumination, lying down, behavioral diversity, and abnormal repetitive behavior. We also found some other indicators, but we had planned like a specific study setup, which Kamille will tell you more about soon. So it had to be something that also fit into this study setup. And in the table, you can see some of the corresponding behaviors to these welfare indicators. So that's how we try to observe and look for these different welfare indicators. The behavioral diversity couldn't fit in there. And also because of the behavioral diversity, we had a quite comprehensive ethogram based on an already very comprehensive ethogram for giraffes that we adapted a little bit through our preliminary observations. And this ethogram consists of 62 behaviors in total. We tried to encompass everything that you can, or basically everything you can see in zoo house giraffes. And we added this to an app called Zoo Monitor that some of you probably have used already. To conduct our observations. And we'll tell us more about the study setup. This one, the middle one.
So we had these 62 behaviors in our ethogram in the Zoo Monitor app, and we did focal observations, meaning that we looked at one individual at a time, and we did this for 10 minutes, 2 times each period, and our periods were morning, midday, and afternoon. And we did this for 3 consecutive days. And we were encouraged to get our sample size up, so we ended up visiting 59 very nice giraffes, and we were also here in Serengeti-Park, and we visited Leibniz in Hanover, and we were also in Kolmården in Sweden. And then we were at all the Danish DASA institutions housing giraffes. And as Paul also just mentioned, inter and intra observer reliability is important. So before we started going out and collecting data, we collected video material and did inter observer reliability on 3.5 hours of videos. Luckily we had a high agreement between each other, which was important for us to look at our data set as one data set instead of 2 separates. And then halfway through the study, we did inter-observer reliability, and we looked at our videos again and scored them again to make sure that we didn't observe too much observer drift. And luckily, this was also we got a good agreement with ourselves. And then what we wanted to look for was short-term reliability in terms of times of day. Does it matter if you look at the giraffe morning or midday or afternoon? And also over consecutive days to see, okay, is there a difference between days? And finally, we wanted to look at long-term reliability. So summer versus winter, because literature suggested that there would be differences here as well. So to our results, we found significant difference in all welfare indicators except for feeding, which might also be because feeding is very much management dependent. So when using the indicators we found in the way we used them, you should conduct your observations multiple times of day, which is not necessarily very feasible. It would be nice if you only had to do it once a day and you could decide yourself. And for consecutive days, we found a significant difference in feeding and behavioral diversity only. And this might make sense for behavioral diversity, which might not be so good an indicator for a study like ours because it needs many different behaviors included. So for observing for consecutive days, that's not necessary for all the indicators, luckily. So for seasonal differences, we were very curious about this because literature had indicated that there would be differences. And also because when talking the anecdotal stories from the zoos we visited, they said that they saw, unfortunately, more abnormal repetitive behavior during winter because giraffes are adapted to warm climates, so they can get rid of excess heat, but they're not very good at retaining it. And also because there are less leaves on the leafy browse during winter, and they spend more time indoors. We found significant difference in all indicators except the rumination. And this suggests that observations should be conducted across seasons. So we found an increase in behavioral diversity during winter. And social affiliative interactions, we found an increase in as well. Lying down
went down during winter, but that might also, like lying down, we have it as a behavior, but it's also very dependent on housing and substrates. So we saw lying down in some zoos and not in some others. So that might also not be a very good behavioral indicator for our study. And yes, we saw an increase in environmental interaction and unfortunately, but not surprisingly, also in abnormal repetitive behaviors. And it was within seasons, we saw a difference here in abnormal repetitive behavior, and we are aware that that doesn't necessarily tell anything about the current welfare status. That can also like come from past suboptimal conditions, or it can be a coping strategy. But we also found literature indicating that it can be used when it's used over time, and you're looking at it, many times. And we chose to look a bit more at this because it's the behavior we found, or the indicator we found most used in literature, maybe also because promoting positive experiences is newer than avoiding not so, more negative emotions. We found 2 studies with quite a large sample size. So Bashar sent out a survey to a lot of zoos and got a reply back from 214 giraffes that around 80 of them showed abnormal repetitive behaviors. And here's like oral, like tongue licking or tongue playing, the most dominant one. And then a newer study of 66 giraffes that said that like 100% of the individuals showed abnormal repetitive behavior. And this is similar to our findings that suggest, or we found in a little less than 90% of the individuals, at least one session had some kind of abnormal repetitive behavior. And the 10% where we didn't see it were the very young animals, so calves and newborn.
And this, then just finally for the results. So we use these like 7 different welfare indicators, and mostly we found a difference in like the time of day, but not between consecutive days. And we did find a seasonal difference. And for seasons, it should be said that we only went back to the Danish zoos. So the Danish observations were conducted both winter and summer with exactly the same method at the same observation times. And since there are some management differences between summer and winter, and like feeding times change, then some of the seasonal differences may also be due to this like management change. And because we didn't do any work on like aggregating indicators and like assigning relative weights, we can't really say something about like it's better to be a giraffe in winter or it's better to be a giraffe in summer. But future work could possibly work on like aggregation scores. Some other interesting future work could also be more work on like validating indicators. So more work on finding out whether an indicator actually measure what we intended to measure. Also for the indicators that we used. We also got some inspiration from cattle literature because more work has been done on like validating in farm animals. Future work could also like include possible correlations. So we have the data for this, but we haven't done the analysis yet. But if some of the indicators are like highly correlated, then maybe you don't have to look at all of them. For example, this behavioral diversity requires like a really long ethogram. But if behavioral diversity is correlated to environmental interaction, for example, you can just look at the environmental interaction. And then finally, like our method might not be completely suitable to all of the indicators. As Kamille mentioned, lying down was quite rare for us to see. So maybe it would be more relevant for this indicator to do it like throughout a whole day, maybe with like data loggers on the legs of giraffes. We've seen one study using that. And then see like, do they lie down at all? How much time do they spend lying down as a proportion of a whole day? And maybe the same with feeding, which is a quite frequently like observed behavior in our study. Maybe it's like too frequently observed to be really like used as a welfare indicator. It might be more relevant to like use it as a like proportion of time during a day spent feeding. So there's lots of more work to be done on these behavioral indicators for giraffes. But thank you for your attention, and thank you, Edu, for letting us observe your giraffes and for inviting us to this conference.
So I don't know if anybody has questions. We have time for 1 or 2 questions.
Thank you very much for the presentation. I have a question about how we judge stereotypies that are repetitive behaviors. We just screened data for carnivore and we quantified locomotion and pacing. But when you looked at the sequence, it was locomotion, pacing, locomotion, pacing, locomotion, pacing. So it was like a fluid thing. So here you showed in winter they feed more and they have more oral behavior. So if the oral stereotypy is accompanying feeding behavior, personally, I would judge it completely differently than if the animal is lying down, standing up, and the first thing it does is play with its tongue. Can you do something like the temporal correlation between different behaviors, except just say the percentage of that?
Yeah, I think we could do that in our data, and it would be highly relevant, is our impression. Both for feeding with giraffes, like some giraffes ruminate and do some repetitive behavior at the same time, and also with environmental interaction, where they do a sequence, but in between the sequence, they also do just some licking. So we tried to separate, like for environmental interaction, we tried to separate out the abnormal minutes, like the minutes where abnormal was scored in the same minute.
Yeah, it's environmental. We removed that because otherwise it would be a positive and a negative, yeah, correlating. And the same as feeding, like if they were feeding and then doing it, we wouldn't count. Like if they were having feed in their mouth, we wouldn't score it as abnormal repetitive. That makes sense. Or answer.
That's on the level of recording. The
Yeah.
question is on the level of where can we sort the observation? When does it happen?
Yeah.
You're saying it does happen during feeding.
Yeah.
We're just not counting it. But if it happens a lot during feeding or associated to feeding, that's an important result.
Yeah, definitely. Also, it is seen in the wild, and there is like suggested that it's also helping with the rumen pH. So it is a bit of an indicator where you have to,
But I think we could also look more into our data because, like, of our method with 1-0 within minutes, we could identify minutes that have both feeding and abnormal behavior. So some of the definitions we found of abnormal behavior, it's said in the definition, like in other studies, that it should be after a certain time, after like following feeding, so that you didn't get the like oral abnormal behavior with the feeding. We didn't have that specific time, but if it was like while feeding, we didn't score it as abnormal, which might have been a mistake. But it seems to be quite linked for giraffes.
and should be investigated more. Definitely.
Yeah.
I just wanted to ask if you noticed slight differences between the size of the enclosure for the giraffe in the different institutions that you visited.
Yeah, so we've tried to like get information about all enclosure sizes. We have gotten that for most zoos. We haven't done any statistical analysis on it yet. But our impression is definitely that there are some differences, but also depending on the management, so whether like they're always fed in the same place of the enclosure, or if they have to like go and like look at different places to see where there could possibly be some food. But we haven't scored enclosure use either, and that could also be highly relevant.
Yeah. And also this whole breeding that Marcus talked about yesterday, like if we see more behavior that we would like to see, if they are able to breed or not, because there's also a big difference between parks. So we also discussed that, but just didn't have time to fit it in. There's a big, it seems like they have more to do if they have an active breeding male and have like different ages in their group. Yeah.
Okay, perfect. Thank you very much. So we will now move on for the presentation of Daniel Maloney via online. Daniel is a PhD candidate at the University College Cork in Ireland. Currently focus on examining the contributions of captive zoological collections to the conservation of species, both in captive and wild projects. Daniel is affiliated and supported by Fota Wildlife Park and the Research Ireland. He graduated from UCC in 2019 with a bachelor in zoology, and since then has pursued a career in applied research to inform the welfare of captive species and the success of conservation efforts. And he will present us with a talk with the following theme: a step towards advancing mapping and spatial analysis of zoo animal data.
Thank you very much for having me today, and especially thanks to Edu and her team for accommodating me last minute when my plans changed. So as they said in my introduction, I am a PhD student in Ireland, just coming up on the last few months of my PhD. And I'm working with my supervisory team, Ruth Ramsey, Courtney Collins, and Paul Holloway. So today I'm going to go through one of the chapters that I'm working on, looking at spatial analysis in zoos, how we can potentially improve spatial analysis going forward and use it to improve the welfare of our animals in captivity. So through a conversation with one of my supervisors, Paul Holloway, who specializes in spatial ecology and movement ecology, we realized that zoos have lagged behind in the development of spatial analysis. There have been advances, but we have become over-reliant on a couple of key indices, specifically looking at spread of participation, the modified spread of participation, and electivity indices. So if you're unfamiliar with this, the modified spread of participation is a index where you can divide up an animal's enclosure into uneven areas dependent on specific points of interest, like feeding locations, locations of shelter, areas of high visitor presence, and you can measure the presence and absence of the animals in the different areas to give you a value between 0 and 1, showing whether animals are using these areas of their enclosure evenly or unevenly. So the closer to 0 that the value you get is, the more evenly the animals are using their enclosure. So this has been used in quite a lot of studies related to spatial analysis in zoos, but we wanted to see where can we go, what boundaries can we push with this. And there already exists a huge toolkit of spatial analysis methods that have been developed for quote unquote wild animals, especially using software such as QGIS and ArcGIS. But the difficulty in using those is that they rely on latitude and longitude coordinates, which for most collection methods in the zoo are not used. For example, for this project, we use ZooMonitor for collecting data. And ZooMonitor is a very useful tool. It's a software created by Lincoln Park Zoo in the States for collecting welfare, behavior, and spatial data. But when you use it for spatial data, it doesn't use longitude and latitude. It rather uses a custom XY coordinate for spatial points. So then we run into an issue of data translation. But what we did was we looked at what ZooMonitor puts out, which is these type of heat maps. And we said, well, they're useful, but they come with limitations. I'd also, before I forget, just say some of my slides are marked with the no photo image. That's mostly just to let you know that this work is in review. I don't mind if you're taking photos for your own self-interest, but I would recommend just don't use it for anything beyond that, because it probably won't be the final version. But just for your awareness. Anyway, back to the Zoo Monitor output. You can create these kind of dynamic heat maps from any data you collect on Zoo Monitor software. But the difficulty here is in these images of the data we collected, Photo Wildlife Park is on the left and Dublin Zoo is on the right. There's no scale, there's no orientation. We don't know the unit being used for the heat map. What is the distance used to generate these points? And we don't have any relative distances or areas between points of interest. So it can give us some information, but it is limited in what it tells us about the use of the enclosure. What we did was we created a method of translating the data from Zoo Monitor into QGIS, which is a software based, like I said, in longitude and latitude. So the method we use for translation is based off of the image you upload to Zoo Monitor. It takes a little bit of work to do it, but once you have created the translation file, which is essentially just a reference file in Microsoft Excel, you then can use that for any project working on the same enclosure. Most enclosures will have some element of a large scale like these. You can also use it for smaller indoor enclosures because you can use images referenced to blueprints, etc., in QGIS to create these maps that you base your translation off of. Once you have translated data, which would require a much longer presentation to go through, you can use pre-existing tools in QGIS to start giving you outputs that are much more detailed and give more information than just the heat map provided in Zoo Monitor or the modified spread of participation index on its own. So here we are showing some simple analysis tools that take 10 to 15 minutes each to learn once you have the data translated into QGIS. And this map is showing our results in Photo Wildlife Park. We have 4 species in a multi-species enclosure, and those are zebra, oryx, giraffe, and ostrich. So you can see the color code there on the right-hand side. In Figure A, we're just showing all of our data collected for the project, split by species, and you can start to see immediately some patterns of enclosure use being like seen between the different species. In image B, we're using 2 tools. The first tool is the mean coordinate. So that is what it says on the tin. The QGIS calculates the mean coordinate of the data that you input and shows you the average point or location that this species or group of data points can be found in the enclosure. We then include with that the standard distance. This takes the first standard deviation, so essentially the 68% of your data that is most closely found to your mean coordinate, and plots the distance that that covers, roughly. So it's not exactly 68%, but it's between 68 and 70% of the data points that you upload. Now, an issue with that is that we do see these data points starting to expand beyond the boundary of the enclosure. So there are some limitations in this, but it does narrow down the area of the enclosure that is being used by these animals. So it starts to show us a little bit more detail of where the animals are spending their time predominantly. If you advance that a little bit further, you can use a tool called standard deviation ellipse, which uses the similar steps of finding the mean coordinate and then taking the first standard deviation around the mean. But in this one, it also takes into account directionality of that data. So we can actually see for that first standard deviation of data, where the animal is moving around their enclosure. So this narrows the focus of that first standard deviation a little bit. It gives us a more narrow focus of where the animals are actually spending their time. And it gives us a directionality of that data of where the animals are moving. So for example, looking here at C, orange represents our giraffe, and we can see that they spend most of their time moving around this kind of corridor. And I can tell you that at the bottom of this corridor is the entrance to their nighttime enclosure. And up here towards the middle of the enclosure, this is up towards the main viewing platform for the visitors and also some of our feeding poles. So just by doing some simple basic analysis with this, we can start to understand more about our species. We can also start looking at the crossover of species, understanding if they're spending time in the same areas, are they avoiding each other? And if we move on to Dublin Zoo, sorry, froze for a second. We can see similar patterns here as well. So we can see that while initially we might see trends of the animals using all of their enclosure, when you start narrowing down the focus to that mean and the first standard deviation, you can see that the majority of their time is actually spent in very specific areas. So you can see again for Dublin Zoo, we have 3 species, zebra, oryx, and giraffe. And when you start to narrow the focus down from all of your data to the first standard deviation, to the first standard deviation with directionality, each one of these narrows the focus of where these animals are spending time. Again, take the giraffe for an example. Their entrance to their nighttime enclosure is over here, while the feeding poles and main viewing platform are over here. So we're starting to see a common trend here between at least those 2 species when you start to look at very high-level basic analysis. If we were to go one step further, and we can use something called kernel density estimators. So these are essentially heat maps and use a similar process as Zoo Monitor, but in this we are able to customize the heat map more specifically to what we want. So Photo Wildlife Park and Dublin Zoo are on very different scales. You can see there that Dublin Zoo is about a quarter the size of Photo's enclosure, but we use the same scale for generating heat maps across these 2 enclosures. So essentially we put in that we wanted a 5 meters radius to be set for the kernel density. And what that does is this tells the tool to count all of the data points within a 5 meter radius of each other data point and give us a heat map based on the density of where the animals are actually being located. So up here, if we look at the plots for our giraffes again, we can see that again, their highest density is being shown around the entrance to their nighttime enclosure. This may lead to questions being asked and answered about their activity levels, why are they gathering in these locations, etc. If we look at the modified spread of participation for these animals, we can see that we do get results showing that they are using their enclosures more towards an uneven end. So I think earlier I may have said things backwards with 0 being more even. I want to just correct myself. 0 is more uneven use with the modified spread of participation, and 1 is more even use of that. But very quickly, because I'm running out of time, this information, while useful, on its own provides us with a very limited view of what is going on. If we go back and view the kernel density estimators, when we start to use that information alongside other metrics, we begin to see the highlighted spots that are actually in use by different species, which can allow us to make educated, understood changes to enclosures, which may help benefit the welfare of these species. So I'm quickly going to skip over this because I don't have time. But one other thing that you can do then moving forward is these tools that I've shown you today are very basic surface level tools. They don't involve any modeling. They're very easy to learn, but they give us a lot more information. And when you start to dig into the more advanced tools that are available on the software, you're able to do things like this, where you can visualize this data in real time and get a dynamic understanding of how animals are moving through their enclosure across their day. So I quickly just thank my collaborators and my funding body, and I will leave it there. Thank you very much.
Thank you, Daniel, for your presentation. Does anyone have any questions for him at this time? Okay, so we thank you once more, and stay on. We have, I think, 2 more presentations before the end of the streaming portion. All right. So I'm going to introduce Dr. Marco Gamba. He actually sent us a pre-recorded presentation, so that's what we will be viewing. He is an associate professor in the Department of Life Sciences and Systems Biology at the University of Torino. As a biologist, he has a background in ethology and behavioral ecology, with strong skills in data analysis using statistical and machine learning techniques. A recurring theme of his research activity has been technological innovation in the field of behavioral studies, where he has been particularly focused on studies of animal acoustic and visual communication. His pre-recorded presentation will be about Boris, a flexible free software for behavioral analysis, which he developed with Olivier Friard. So when we're ready, we can just play the pre-recording. Thanks, Jan.
For the Zoom meeting of April 2 to 5, 2025 at the Serengeti-Park. I'm recording this as of December 17, and I know that a lot of people would see this online, maybe before the date, but I hope you can enjoy the meeting and have a good time then trying our software called Boris. So this presentation will give you a brief introduction of what Boris is and what the kind of functions you can find in this software. Everything I'm gonna tell and I'm gonna present is reported in our web page, which is www.boris.unito.it. So why we developed Boris? At the time we started at an evolution of behavior master's degree at the University of Torino. We had a lot of students coming to our department, our university, and every year we should provide software to these students. And then at the time we were using a commercial software that was very popular, but was very expensive. And there was especially something that was very annoying for us, which was that you got to provide a proper computer, an appropriate computer with particular characteristics to the students. And this was very difficult for the increasing number of students we had at the time. So we decided to develop something That was something a bit different, that was based on open source technologies, and we could provide for free and could be used over different platforms and different computer models. And Boris answers a couple of questions that were very critical at the time, but even more critical as of today. We know that quantitative aspects of the study of behavior and human behavior are increasingly relevant to test hypotheses and to find empirical support. And this is what the journals are asking us when we wanted to, when we are submitting our papers and we want to publish our papers. And at the same time, photo and video cameras can now store a very large number of video recordings or pictures, and very often we monitor subject remotely. And because of this, the amount of stuff we collect is getting larger and larger, and the numbers are getting bigger and bigger. And it's very difficult to do a proper analysis for what we get, or at least part of what we get, without appropriate software that can be part of our workflow. And it's very frustrating when you don't have the proper tools to flexibly work with in different situations with different species, and very often commercial software are very much constrained on a particular species, on a particular situation. When we thought of Boris and when we started developing Boris, we had in mind that the software should be easy of use, flexible, and as said before, part of an efficient workflow. And we immediately thought to something free and based on open source technologies. And the Boris is available for Windows, for Linux, for Chromebook, and hopefully there is a Mac version coming back again soon. We also have a version for Android if you want to try it with your tablet or your phone, but it's not for iOS, just for Android. It's also possible to run Boris on those small computers that many of us are using as a sort of toys, and they are very cheap, as you know. At least they were very cheap. And for example, one of those is Raspberry Pi. As I said before, we wanted to have something that was applicable to different species. And in fact, what you see from the publication using Boris, you have a wide array of species that we would not be able to imagine when we started developing this piece of software. And now I come to the Boris functions. What is Boris? Boris is a software that you use to log events, and you use it to log events by starting a particular event by pushing on a key on your keyboard, and you stop that event by pushing on the keyboard key again. And what you see is that for states, of course, I'm not getting to the details of what is behavioral analysis, because most of you will know about that. You might have a start and stop because you have a duration. For events that are conceived without a duration in your project, you can, of course, just push once. With Boris, you can have event logging of videos or audio recordings. This is the most popular situation. You have a video recording of animals that you recorded in the wild or you record in a zoo, and you want to score those videos by using Boris, by pressing the different keys. And please refer to our guide for more. Or you may be interested in a live observation coding. So you're looking at the animal, you're in a zoo, you're in the wild, and you have your Ethogram set, and you're looking at the animal, you want to press your keys while the animals are doing a particular behavior or something that you want to track in your observation. You can also use Boris when you want to code a set of pictures. So, for example, what happens for the output of camera traps. And I'll come back to this briefly later if I have time. With Boris, you can configure an unlimited number of subjects, an unlimited number of behaviors, an unlimited number of modifiers, or independent variables. So those variables you want to add to your observation, for example, the number of visitors in a zoo, or the weather, the temperature, or the degree of cloudiness of your sky. And you also can have an unlimited number of observations that might be consisting of one single video or a set of videos that you recorded on a particular day. And you got to remember that for the formats that are accepted in our software, you can refer to those used by VLC or MPV libraries that are very robust media players you can find online that are incorporated into the software. You may have different playback speeds, and you may have up to 8 media files synchronously played. So, for example, if you have a scene in which you have multiple cameras, you can have up to 8 media files at the same time. And of course, then there is a number of different formats that you can use to export your data and to export your data to other software. I just put logos of the different softwares we are used to put in the process of our analysis when we're using Boris in connection with those other parties' software. You may have also different outputs. One output, of course, is activity budget. All of you will be familiar with, or behavioral transitions, or again, events plots. And those kind of diagrams are very popular, and you can produce them within Boris. And of course, you can imagine to extend the different functions we have with what you want to do for your own needs, because, as I said before, this is an open source software. So it's not only what we've done, but also what you can add to the functionalities we thought about. And this is the citation of Boris, Freja 2016, Methods in Ecology and Evolution. It was a very popular paper, and now we are up to 2,000, almost 2,000 citations as of today. This is not updated, unfortunately. And with this, I can just tell you to go to our Boris user guide if you wanted to have more, and to the different sources of information. You also have a lot of user information on YouTube, for example, with video of different viewers in different users in different language you can refer to. And thank you so much for your attention, and I hope to see you in person again soon. Please get in touch with us if you want to know more. And a couple of times a year, we also find time to do in-person presentation at different universities all over the world. But of course, this is constrained by our duties in the University of Torino. Thank you so much for your attention. And I will leave you with this.
Well, thanks a lot, Dr. Marco Gamba. If anyone wants to see his presentation, we can make it available because it's a pre-recorded video. All right, so we have Niek Wilmink. Start your screen. Here. Okay. Hi, Niek. Whenever you're ready, you can share your screen.
Okay, no problem.
Thanks so much.
I had a little bit of problems getting in. So here we are again. Okay. Shall I start?
Yeah.
Wonderful. Thank you, everybody, for being here. It's an honor for me to be presenting today for you, especially when it's such a lovely day. It's sunny and 21 degrees Celsius here in the Netherlands. Unfortunately, I cannot be live there, so we have to do it with this. I would like to present the Noldus tool for animal studies for you. And to give you an idea who I am Niek Wilmink. I'm product manager of The Observer, Viso, Media Recorder, Face Reader, quite a lot of products at Noldus, mainly because I've already been 16 years at this company. I'm married for 27 years with Marianne, and I have 3 kids and a dog. And yeah, the latter is, of course, the most important member of the family. At least that's what he thinks. Noldus IT, we are a professional developer of software and hardware, and we integrate that software into all kinds of solutions for behavioral research. And here's our mission statement, as we officially say. And yeah, we try to contribute to a better world, to increase the quality of life. That's something that we do through product development, software product applications, hardwares. We train people, consult people, and once every 2 years, we sponsor the Measure Behavior Conference. And about system integration, that's the software together with the hardware and all kinds of computers and video and all kinds of things that go with it, including tags. We strongly believe that innovation can be met through collaboration with all kinds of universities, organizations such as National Institute of Health, Fraunhofer Institute, large corporations such as Philips and Roche, but also instrument companies that we try to work together to make a better solution for our customers. So today I'm going to talk about 3 products. The Observer XT, that's a coding tool to study behavior of wild and domesticated animals. And Viso, that's a recording tool for recording and video recording, which may be used in multiple rooms, but you can also record on your cell phone or handycam videos in the park and then import them into Viso for storage and for further analysis. And finally, I would like to introduce TrackLab, which is a software for spatial behavior recognition and analysis. That means how animals and people move around. And you use sensors such as global positioning system sensors or ultra-wideband sensors for that. The clients we have are a lot of customers around the whole world in 90 countries, from Canada to South Africa, and from South Africa to South Korea, everywhere around the world. We have a science track record with almost more than 50,000 articles in various applications, a lot on human psychology, but also zoology, ethology, human factors. In fact, ethology is where we started from. Now, to those tools, and first we'd like to state the Observer XT. Very proud we say that it's a gold standard for coding and analyzing behavior. That's something that we read in an article, and we are most happy to copy that, of course, as you can imagine, because yeah, it says something that about our tools. You can code behavior live or from video. You can use all kinds of data streams and integrate that with your video data and visualize that and present the data through the Observer. Calculate basic statistics, and very important, you can work in a team with your co-workers. And there's a reliability tool in the Observer XT later. And there's a function to code on the go, take Pocket Observer out in the field, and then get back, import it back into the Observer to analyze your work. So what you can use the Observer XT for welfare, animal welfare, to see how they socially behave, or if there's any stress or other kinds of behaviors. Animal training, for instance, it can give you great insight into the response of the animal, as well as, of course, how good you are. Wildlife ecology, and for that, of course, if you go out into the wildlife, into the forest, Jane Goodall used the Observer XT, for instance, to take your lab on the go and make that more easier. And finally, insect behavior, that's where the Observer XT started, with behavior from caterpillars and wasps, and how they react to each other. And Lucas Noldus, who gave his name to the company, started out with that, and he was doing that all manually and thought, okay, this could use a video so I can look back at it in the office and pause it when I need. This is how the Observer XT looks. As you can see here is a single video, but you can use more than a single video, up to 20 if you want. That's quite a lot, of course. You need a big screen for that. But for instance, this video, you can easily use playback control for fast playback, slow playback, or even backward playback. And the visual representation of your scored behaviors is updated even while scoring. So you see here activities such as approach and flee. When a monkey flees from another monkey, you can press a key and then it appears automatically in this visualization screen. And of course, while fleeing, it's not approaching, so it stops automatically the approach. The table, there's also next to it a table with scored behaviors, so you can really look into the details of, okay, what's going on at that exact moment. For instance, for insect studies, that may be very important, but also for other studies, of course. So what is behavior and how do we measure that? Behavior can be quite large, and note, I will get back to that later on. It includes all kinds of activities. I mentioned before fleeing and approaching, but also all kinds of interactions, social, sexual, vocalizations, screaming, shouting, the animals, movement, body postures, etc., etc., etc. It's a lot. But basically, the observation and behaviors is just recording who does what, when, where, and with whom. So who is the subject of your analysis? That may be one, but maybe also more. For instance, you may be interested in the small monkey in this still image, but it can also be that you are interested in all three of them because you want to study the social interaction. And what is that? That may be fleeing behavior, but it may also be, as in getting the fleas out of the animal. But it can be all kinds of behaviors, of course. The time is recorded automatically, like most products nowadays. The where could be a modifier, could be up on a tree, could be in this platform, could be on the ground. And with whom is, well, that's a social interaction, or with what tool, it can also be a modifier. Now, some tips. We recommend to split up the body and code each part. The paw, the mouth, the eyes, code them separately. And limit your coding to what you really want to know. If you really want to know how this poor sheep ends up with 5 legs, yeah, then concentrate on the paws and do not concentrate on the mouth, for instance. Subjects can also be modifiers. So using key codes make it very easy. These are on the keyboard. And the Observer XT allows you to use those same coding codes for different topics. So for instance, this sheep, Ashley, approaches the sheep, Alice, and you only have to code A, and then that's for the subject, and A for the approach, and A for the modifier, Alice. Makes life much easier and coding much faster. And finally, when you have everything coded, you can explore that visual, like I showed you before in visualization, but also select those interesting parts and then export these to a specialized statistical program of your choice. Those statistical programs know much more and are much more sophisticated than the Observer XT, but that's why you can easily export it to them. Statistics is very important for all analysis, and the Observer XT has some descriptive statistics, most descriptive statistics, I should say, which you can use to measure frequencies, duration, but also the maximum, minimum, and the mean. If you want to get rid of your outliers with the maximum mean, that's very easy in the Observer XT. Now, there are three special analysis forms in the Observer XT, which is a lag sequential analysis, and that's an information about how often an event is followed or preceded by another event. For instance, this little deer, that looking up may be followed by biting, for instance, or maybe followed up by fleeing. And if that is something that happens often, then lag sequential really helps you with that. And it may also be that it's not immediate, that between the looking and the biting behavior, there are 2 or 3 other behaviors. And that is something that you can easily recognize with the lag sequential behavior. Very powerful. If you use co-workers to code on a project, then the reliability analysis is very useful, because then you can see if they agree or disagree with the data sets, especially if you use Pocket Observer to go out and have your co-workers code all kinds of observations, bring them back in the core user, the Observer XT, and then use a reliability analysis to compare those results with each other. And finally, there's a latency analysis, investigate the relation between stimulus and response. That may be, for instance, a ball that is put into a cage of an animal and how they respond to that stimulus. I mentioned it before, the Pocket Observer is observed on the go. That can be used by you or your co-workers, which gives you a lot of freedom. You can even bring it to the jungle or to the desert, or in specific circumstances. You can use it to observe unobstructedly. And that means you can also observe your visitors to your park while holding your cell phone or smartphone, a tablet, or rugged handheld. And this has a very easy to use user interface. That's about it for the Observer XT. Another part of the measuring behavior is audio-video. You want to measure, for instance, nocturnal animals, and you don't want to spend your whole night on looking at the video or looking at the screen on the behavior of videos. Just make a video of those animals and then bring them into the Observer XT. Visio is a great tool and a very simple and easy to use tool to measure that kind of behavior, to record those videos. It's flexible, and you can start with a single room, for instance, but then move on to, for instance, the lion den and the crocodile tank, or the monkey reservoir, for instance. You can mark in Visio. There's a very basic marker section in there, about 30 markers you can mark, and those are point events. But you can later on export everything to the Observer XT and do in-depth analysis. And in Visio, there's also a great way of from those markers create video highlights to show in presentations. An example is the Wildlife Forensic Academy in Buffelfontein, South Africa, where Visio is used to train staff to secure evidence against poaching. Poaching is a big problem, and it's a multi-dollar, $13 billion business. And there are large businesses behind that with highly paid solicitors. And you want to make sure that any evidence that you find is really not tampered with. And so the gamekeepers are trained in a special facility, and a special facility, you can see a picture in there of a car and a mock-up of a giraffe. People are trained to make sure that the evidence is here, is preserved and really professionalized. You can read more about that on the noldus.com website in the newsroom. Finally, TrackLab The TrackLab is a location tracking using a combination of body-worn devices and, of course, all kinds of tags and tools to measure. Indoors, there may be ultra-wideband, and outdoors, best used is the global positioning system. It can also be used in combination with a 3D accelerometer, and it's highly scalable. You can start with only 1 or 2 animals, but then move on, and it's very robust in their identification. You can use a fixed or mobile lab for that. A fixed lab can be a cage or a room, a resting room where the animals are staying. But it can also be a pop-up tracking lab where you can bring your track to a place and then tag the subjects and with those wideband tags and use TrackLab to track them. What you can show is then, in this case, this is a CalBar is the way that animals move around, for instance. But more interesting is how is their activity. Get insights in particular events and learn which individuals are active and which are not, or learn how they approach each other and how close they are with each other. Those are 2 behaviors parameters that are presented in TrackLab. So why use Noldus products? Like I said, we have more than 30 years of experience now. We were founded in 1989. We have a huge amount of users and a lot of peer-reviewed publications. And with that, I would like to thank you very much on this beautiful day of attending my session. And yeah, that's it. If you have any questions, do not hesitate to ask me or to visit the website. Thank you very much. Oh.
Thank you very much, Niek, for your presentation and for hanging on despite the issue. Would anyone have any questions for him in the meantime? Okay, so there are no questions in the room, and I don't see any in the online presence. So when they do have questions for you, they will send you an email to the address listed in your presentation. Sounds good? Okay, thanks so much, Niek.
Thank you very much. Have a good session. Bye-bye.
Okay, so we're gonna have a really weird schedule at the moment. All of you can slowly head out because we wanted to have some group pictures. So our lady Angela from marketing is outside, so you can go ahead and start to get set up. For all of us here and from the committee, thank you all so much for joining us. We would end the live stream. Thank you very much for joining us. Hopefully we get to see you next year.